Good. My presentation is about WIS metadata, and I should first start with what is metadata. You have heard quite a lot about it. We have already seen that there's a risk for confusion because the metadata can be so many things. Everybody heard on one occasion or the other about metadata. So now, what is this? Even to the experts, this might happen that there's confusion. I can tell a story. When I first arrived in the Secretariat, we had this discussion over coffee, and people were talking about metadata. And of course, I came from the university, so I knew everything about XML and metadata and so. But as the conversation went on, I think for half an hour, everybody was talking about metadata. But in the end, I realized that we were talking about two completely different things. So it is always imperative when we talk about metadata to be clear what kind of metadata it is we're talking about. But now, so first, what is metadata in general? You see here a couple of tin cans. So guess what's inside? How can we know? Yeah, we should open it, exactly. But now, say you're in the shop, you only have $1, and one tin can costs $1, and maybe your wife has asked you to buy some food. So which one has the beans? We cannot open all because then we have to buy all. So the metadata helps. Here we have the tin can with the label, and it tells us where the beans are, or in here where the pineapple is. Again, this prevents or helps us not having to open all of them, but we can take the right one. So this nice label here is like discovery metadata for tin cans. Now, where's the analogy? Some of you are technicians, so you know in the file system we have files, and basically they contain zeros and ones. And if we have the right program, then we can interpret the zeros and ones so that then we see the image or the text or the movie. But if we open a movie with the word, then it will not make sense. But how can we know what's inside the file? The file name helps. And maybe if we make a right click on the file in the Explorer, then it tells us when it was modified and who the owner is, and so on and so forth. So this is also metadata about the data. Those of you who know about file systems know that the file is stored in one part, and then in another part the file name and the other attributes. So that's also metadata. In general, we say metadata is data about data, but that's about it. Now, there are many kinds of metadata because there can be many data about data. We have the discovery metadata in the WIS. So that metadata helps us to find something. And we have the station metadata also in WMO. In the WIS specifications, we have heard about the distribution metadata. Then earlier again, we heard about observational metadata that can be contained in a PDCF code. It tells us some context about the station. So many different kinds of metadata exist. what makes them metadata? What do they have in common? So the general idea is metadata is data about data. That's after all the word meta. I think it comes from Greek. So and it means that sort of second level information or so. Here's again the example of the Explorer. If those of you having a laptop in front of you, make a right click on the file, then you will see this. And so even here it is called advanced attributes of the file. So that is metadata in its finest form. Also here the others: created, modified, accessed, read-only, hidden. All of these are attributes of the file and thus metadata of the file. Now WMO has standardized the metadata for the WIS, and we know it is discovery metadata, so the metadata should help us finding out, or should help person A that is looking for something to find what they're looking for, and so thus person B who publishes information should provide metadata so that it can be found. But now, which kind of metadata? Should we use tin can labels and stick them on our data, or that will clearly not work? Well, what can we do? We can just write some text file, because really everything can be metadata. Even here, my computer is a Dell computer. The Dell sign here can be metadata about the computer. So, but how can we do this sensibly so that it helps us? Here, there are many possibilities, but what the WMO has done is we have adopted ISO 19115, an international standard for geospatial metadata, as the WIS metadata. So that means that the information we want to provide should be encoded in this ISO 19115 metadata. And that gives a little bit a structure of what kind of information needs to be provided and how they are to be encoded. Here on the right hand side you see an example. It might dawn on you that this looks rather complicated, but we will see what can be done about this and why this is so. The WMO Core Profile version 1.2 provides information or rules how this ISO 19115 has to be used. Why is that needed? As you will later hear, the ISO 19115 is used by many different people with different kind of application cases. Maybe on the one hand, the land registry of the government uses 19115 to map out the land, what belongs to who. Then maybe others, maybe geologists use the standard for their domain. Then in WMO, meteorologists use it for meteorological data. And there are many others. So everybody uses this standard in their way, and it in a way has to be generic enough so that different kinds of people can use it. This means the standard is very broad. Many things can be done. How should we use it in the WMO community? This is specified by the WMO Core Profile. Currently in its version 1.2, it tells us which of those elements in the 19115 standard should be used. Now I'm talking here about elements. You see that the ISO 19115 here is encoded in the XML. You recognize this. I should here say that the ISO 19115 has nothing to do with XML. It just tells us what kind of elements need to be there. So what can be an element? For example, there always needs to be a file name, and there needs to be a contact. And if there's a contact, then the contact needs to have a name and an email address, for example. And if there's a quality control information, then there needs to be also a description of this. Or another element can be maybe the encoding format. And yet another element can be the distribution mechanism. So how can the file that is described here be obtained? Is it a download or is it an upload? What kind of protocol? So you see all these are elements, and there are over 300 of them in the ISO 19115 standard. But what it doesn't tell is how this needs to be, we say, encoded. How does it have to be written down? So if we take the analogy of a meteorological observation, maybe there is some guide that tells us we need to measure the temperature and the pressure. So that would be the ISO 19115. If we measure the temperature, we also need to measure the pressure. Say that's the rule. But then how do we encode it? Maybe as a sign-up. So the analogy here in the metadata is then the ISO 19139. So this specifies how the 115 can be encoded in the XML. So both are very closely linked and are often also used as synonyms. But I have here now explained that the 115 tells us about the structure, what should be, which information should be captured, and the 139 tells us how the XML will then look like that encodes this information. In practice, often what you will do is you will work with the XML directly. So there's really no distinction. But I have mentioned how the 115 and the 139 link to each other. Now, for those not knowing what ISO is a standards organization, much like WMO, but with a bit broader range. So they standardize things, and one of the things they have standardized is this metadata standard. Back to the core profile. The core profile of WMO tells us which elements are useful in our community. That is, for example, the quality information should go where, and the GTS file name should, or GTS header should go where, the GTS priority should be encoded how. All this we find in the core profile. Yes. Is that good? All right. Is that valid already? Good. So as of January this year, probably is that subject to CBS, or it does not have to be confirmed by VC? No. So good. The WO core profile is subject to incremental increases, and here So thank you. There's different versions, and as we develop this metadata, there's comments from the community. We need to also maybe take into account that kind of information. Then we make a new version of it. And I've just heard from the competent person that version 1.3 is the current one. It can anyway be found at the location I will later show you. I should say a word of warning. The ISO 19115 specifies over 300 elements with complex relationships. So, for example, what can we imagine? There might be a contact element, and then the contact element in turn contains an email element and a telephone element and an organization element. And the organization element contains an address element, which contains a street element and a postcode element. And the postcode element contains a number element, so it can be quite complex. And that's the reason why it looks like this. I will now maybe open one metadata file so that you can see how this looks like. So we have here some climate from Doha International Airport, and let's have a look at it. Here it comes, and that is the metadata. It looks quite impressive, but on the other hand, here you see that much of what actually is contained is these red ones, and these are all structural elements, so that's not actual information, it is just structure. Then on the other end here, what is black inside the elements is information. So what do we have? For example, we have here the contact and then the responsible party. Is that, maybe I should zoom like this so you can see better. We have nested, so you know in the XML we have always like a tree structure. So a contact, responsible party, organization name, and then here comes a string, so not a number, a string, and wow, here's the Civil Aviation Authority. And on the other hand, the contact has a phone number, and it's a voice phone, and here's the number. What else is there? Here, which version are we using? Core Profile of ISO 19115, and the version is 1.2 here. So it has not yet, it is not yet using the latest version because it was generated last year. We also, what is this? Here there's a title, and it tells us that it's a collection of climate temp reports from Doha International Airport. Is there anything else? Here even we have an abstract, and again a responsible party. There's sometimes several contacts because maybe one person is in charge of the data, other person is in charge of the metadata. Could be two different people. one thing that is important is how can we get the information. You will maybe see if we go now here back and we look again. It allows us here to get to the product. I hope that it will be now in the cache. Unfortunately, it's not in the cache. So I will try this one. Also not in the cache. Maybe this. So here the cache is full. I can get the file. And also at least from the last 24 hours, all the actual products that correspond to this product here, which is sign up from Jeddah. How does this system here know where I can get to this cache? Where can I get the files? There is in here an element that is called online resource, and I will try to find it. Online resource. And here there's a URL that points to where I can obtain this information. Now, the cache earlier was from a different product, so it pointed to the JISC. In this case here, it points to your website. So you can understand how people, by looking at the metadata, then can come to you. Let me now return with my presentation. So as I said already, the ISO 19139 can be used to describe a variety of geospatial data. The WMO Core Profile in general and its current version 1.3 recommends how in the WMO domain this can be used. If you remember those fields that we have seen, a contact point, an online resource, an abstract, have nothing to do with metrology. They can be used in many different domains. But here in the core profile, it tells us it is in this way it should be done. Now there is one complication I should point out. In the WIS, we want to have as much information as possible. So we also want to accept as DCPCs those centers that are maybe not entirely part of the meteorological community, but maybe from other communities. By having the ISO standard, we make it relatively easy for them to publish their information into the WIS, because we use an industry standard. They can easily encode their information in such a standard, because there's wide support for it. But maybe they are not really meteorologists, so they don't use the core profile, because they maybe use some other profile. So for the WIS, we accept everything that is in the ISO standard. The core profile of WMO restricts. So if we think of a set, then say here there's a big circle, that is the amount of ISO 19115 metadata. And the core profile is a subset of it. For the WIS, we accept everything that is in ISO 19115. However, for the metadata that is about the GTS product, so everything that is really related to our core community, the ISO 19115 in the core profile instance has to be used. What does that mean in practice? If you create a metadata record for something, a bulletin, that circulates in the GTS, then the metadata must be compliant to the core profile. On the other hand, if you create a metadata record for a product that is not available in the GTS, then it only has to be compliant with the ISO standard. Again, think of it in terms of the sets. So the core profile is a subset of the whole ISO standard. Where can you find more information? This online guide here for the version 1.2 is available at this URL, and you can download and read it. It explains all those elements and many others that I have referred to. I want to recall to your minds why we need this metadata. We are talking about the discovery metadata. Here is the DCPC on the bottom right. And the DCPC publishes to the JISC some metadata. How can the JISC and the DCPC understand each other? Maybe imagine there's Croatia and they speak Croatian. And on the other hand, the JISC is Offenbach, so they speak German. How can they communicate? Now, literally, by finding some common language, maybe English, so they can communicate, no problem. Here in the WIS, it is the same thing. Maybe here the DCPC has its own systems and the JISC different system, but by finding a common language, they can communicate. The ISO 19115 is this common language. So the product that the DCPC has is described in the ISO standard and then uploaded to the JISC, so the JISC can understand it. Now, the user can search in the JISC, and since the JISC understands the product, it can give an answer. Here, this is what is available. Then, using the online resource, the user can come to the DCPC portal and retrieve the information, and you can keep it under tight lock if you want to, or apply any data policy that might apply. That is called the DAR, Data Access and Retrieval, in the WIS. And the metadata plays an important role because it is the metadata that is used to communicate between the NC or DCPC and the JISC. Also between the JISC and the user, because the user might want to have a look at the metadata. However, in practice, as you have seen, what we are really seeing when we are searching is something else. We see here the product ID and the title only. And then maybe we can click here on metadata, but we don't see the XML. What we see is the abstract, the code, the URL, maybe some status and some geospatial information. The JISC takes this from the metadata and shows it to the user in a nice way. This here is the JISC in Offenbach, but we can also maybe use another disk, the one in JMA, and you will see that also here we can search and we can find the information and even get more detail here about the contact. Now this is from the city forecast, so it comes from Hong Kong. But there are also others like this one, where the contact here is the Civil Aviation Authority. Good. There are other JISCs that are operational, such as the UK Met Office or Toulouse, and also the JISC Beijing. And I think the other JISCs that have been audited will also become online soon. Now, maybe one question that comes to your mind is why does it have to be so complex? This XML looks rather suspicious. Why do we have to do this so difficult? We could just write those elements we need in a much easier XML file and don't have 300 elements and sub-elements and so. So why did WMO choose to use the complex one and not the easy one? The reason is that ISO 19115 is an international standard. That means different communities understand it. I have already given an example of maybe the DCPC about geography that has some link to meteorology maybe, but also is part of another community. They would maybe want to communicate with us in some way. So by using an international standard for our metadata, we make it very easy for them to be part of our community, because maybe they already have their information available in the ISO 19115. Or if they don't have, it is very easy for them to do so, because many software tools are available to work with the ISO 19115. Now imagine, in contrast, the our other standards, the ones made by WMO, maybe Buffer or so. They are very complex, they're well documented, but they are not very easily understood by a scientist who is not a meteorologist, who is maybe, I don't know, a social scientist or so. It will be very difficult to understand the buffer. On the other hand, the ISO can be used in many different communities. So in that way, we can readily use from others the information, and also others can use easily our information. So again, why is this useful? The relevance of the meteorology goes up because more people can use this information. So that's point number one. But point number two is a more pragmatic one. Also inside WMO, this has advantages, because we don't have to spend years to find the right way to find our own standard to encode the information. We can use a standard that is already available. Then we can use a software that supports ISO, and we can readily use it rather than developing our own software. Or we can use a computer library that supports the ISO standard rather than writing our own library. So in that way, we build on what exists, and that makes it easier for us to concentrate on what we really want to do. Not developing information management standards, but to make a good forecast and provide a good service to our users. So that is the reason why the ISO standard was adopted for the management of the discovery metadata. However, now you don't need to worry about this complex standard. In the day-to-day activities, you don't need to mess around with these 300 elements. It is really so that only about 20 fields, very pragmatic fields, title, contact, data policy, where can I get the data, etc., need to be managed. So what we can do is we can have an easy editor with some fields that can be filled out. Of course, maybe the technician, he needs to understand and set up such a system once. But then the meteorologists, the administration, they can use the tool, and it will be easy for them because what they need to fill out is just some forms. We will see how this works, for example, with Excel tomorrow. There can be an Excel-based system where just you need to fill out some fields in Excel, and then it will make the metadata record for you. Or you can have an online system where there's a web page that you fill out, and in that way you manage your metadata. So the complex XML generation is done in the background and is hidden from the day-to-day user. Here are some pragmatic tips how to manage metadata. Of course, you can create for yourself from scratch. You can read the guide and then make a record for yourself. But this will take probably very long. So maybe it is easier to manage the metadata in the cloud. So for example, in a JISC. A JISC might have some online editor available for you where you can authorize and then see the metadata records you have and edit them there conveniently. It is just like maybe doing some online transaction or so. No need to understand the complex XML. On the other hand, a more sophisticated center that has a lot of data maybe doesn't want to do online click and fill out for all the maybe 200, 2000 products. So then you can have your own metadata management system. So maybe you already have a database in which there's a table that contains the different products you have. So then you can write some small program or so that loops over the database and creates a metadata record for all the products that are in the database. And your programmer can make a nice interface to the database where people can input new products or modify, and also things like changing the contact person when maybe somebody is promoted. Then we can do this automatically without having to fill out 200 or 2000 times the online form. Then how can we maybe leverage what exists already? It is always recommended when you make a new metadata record for some product, you can search in the JISC for a similar record and look at the XML structure there, and maybe it suits what you need and you just change the information in there so that it is your information, but you have taken the structure of an existing metadata record. Also, I think templates for different kinds of things, so maybe for a forecast or for a data series can be made available so that you use the template in the same way you use when you make a Word letter. You can use a template where the structure is already given and you just need to input the information. Here My last slide is about how such a metadata management system could look like um, when we're talking about connecting this to a JISC. So you see here is the JISC on the top right corner, and here is now inside the National Center or the DCPC a thing called an OAI provider. What that is will be explained later, but it makes available the information in form of metadata of the organization to another organization, in this case to the JISC. And inside the organization there might be different kinds of products, so maybe a database with surface observing stations and another database with upper air stations. So maybe there's a metadata generator script. It runs every day or so and makes an export of these two databases and puts the result into here. Then maybe there's also some other products that are really not in a database because they're very specialized, such as maybe a city forecast or some specialized dust warning and maybe some marine model or so. There's no reason why this would be in a database. So we can use a metadata editor, such as maybe a GeoNetwork or the WMO metadata editor. So we can manually edit these, and also they will provide the metadata to the OAI provider, and it goes to the JISC. Maybe OAI provider you can also substitute by something else. You can upload by FTP or so. The point is it needs to go to the JISC. So I have spoken about metadata, what it is, the metadata, and what kind of different metadata there exist. And then I have explained about the discovery metadata. That is what we need to do in the WIS. I've told you why the standard is so complex, but also that you don't need to worry, because in the daily day-to-day business your technicians will find a way how to hide this complexity. I have, on the other hand, given some hints how this can be understood and what kind of technologies can be used to make this easier. And here finally a design that is used by many GCPCs and NCs to collect or to make available for collection their metadata. Now you will, after the theoretical introduction, you will see how these things are implemented on the ground, and tomorrow we will have some hand-on training on how to really work with this metadata. Thank you very much, and then we will take some questions maybe, and after that we will have time for tea and coffee. Yeah, because of the same reason I said earlier, the XML is a standard, and many different softwares already support reading XML. ANSI format, it is difficult to structure information in ANSI. So yes, you can have text, but how do I know what is the telephone number and what is the fax number? You can say maybe I make comma separated values, but you have seen that the ISO standard is very complex. You can model many different things. So maybe the contact doesn't have to be there. But if the contact is there, then there needs to be a telephone number and a name and a fax number. So how can I do this with comma-separated values? It is very difficult. Either I always have all the million fields that are possible, so then I have million commas that are all empty and just 7 or so filled out. Yes, no, because in the XML, if the contact is not there, it is just not present in the XML. So the file size is smaller, and yes, that it is mostly the metadata is not so big, so that it's more about how can I encode the information that I want to encode. If I do it in ANSI, I will very quickly hit a limit on very practically on how to encode this. It is in a way really the same thing as Hasegawa-san yesterday explained. In the sign-up, we have decided, okay, here's the sign-up, and this goes there, and this goes there. But then what do we do if we need a new field? Then we need to define sign-up version 2. And then we need again a new field, so we need sign-up version 3. So then again something else, sign-up version 4. So many sign-up formats, not possible. What we should do is we should have a code where different structures can be inside. Like the table-driven code, we update the table. The structure information is in the code. In the XML, this is similar. The structural information is also contained in the file by these different elements. And now, of course, we can make up some kind of pseudo XML in the ANSI. But then we have sort of reinvented the XML. Again, maybe XML is not perfect. There are other ways. But the XML is understood by many different people and also by different software. So we don't really need to invent all this on our own. We can just use something and focus on what our business is, not encoding really, not of information. Oh yes. I think maybe we should also we should not forget that this is about information management. So maybe for the code, the metrological code, the XML might not be suitable, or maybe yes, suitable. You see ICAO, they say yes, others say no. But this is not about data, metrological data, not about observation. It is about information. And here, really, the XML is made for this. So we can use it. And anyway, we have had long discussions about if this should be used, yes, not. Now the Congress had said we should use it. So now that's what we need to do. Yes, so the question comes often, why the XML? But you can be assured now many different communities, often marine XML there is, and so it seems that people think it makes it easier to exchange the information. even in a way, here, you know, when I look at the source code of the web page, it is also a dialect of XML. Yes, but HTML is a dialect of XML. So it is a core profile in a way. It's the HTML core profile of XML. Now it is hanging, but now, yeah, here. So we see there's these elements, you know, open, close. That's really XML. Good. Then thank you, and let's have some coffee.